This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Ever wondered how things move differently on a spinning planet?
It's all about perspective, really.
We're talking about the Coriolis effect and a 3D simulation that brings it to life.
It's mind-bending, but this simulation makes it surprisingly clear.
So this simulation shows the Coriolis effect from both an inertial and a non-inertial frame of reference. What's the difference?
Imagine you're on a merry-go-round. From your perspective, things seem to be moving strangely, right? That's a non-inertial frame.
So like if you throw a ball, it doesn't go straight?
Exactly. But from someone standing still watching you, the ball's path looks perfectly normal. That's the inertial frame.
This simulation uses a rotating sphere, right? What do we see happening?
You see particles being launched from different points on the sphere. In the non-inertial frame, they curve due to the Coriolis effect.
Right. But in the inertial frame, they travel in straight lines?
Precisely. The curvature is an illusion created by the rotating frame of reference.
The simulation lets you adjust the camera angles too, which is pretty cool.
Yeah, you can get a really good 3D view of the particle trajectories. It helps to see how the effect changes with different launch points and speeds.
And there are those magenta arrows showing velocity vectors. What's the point of those?
They show the direction and speed of the particles at various points, making it easier to understand the deflection.
The description mentions the Coriolis force as a fictitious force. What does that mean?
It's not a real force like gravity or friction. It's an apparent force that arises because we're observing motion in a rotating frame.
So it's a consequence of our perspective, not a physical interaction.
Exactly. It's a useful concept for understanding motion in rotating systems, though.
This effect is more than just a physics curiosity, right? It has real-world implications?
Absolutely. It affects weather patterns, ocean currents, even the flight paths of long-distance projectiles.
So like hurricane spinning.
Exactly. The Coriolis effect plays a significant role in their rotation.
The simulation credits Fu Pun Huang, Tan Wei Chong, and Lu Kang. Impressive work.
They've created a really valuable tool for learning about a complex concept. It's a great example of how simulations can make abstract ideas more accessible.
It's definitely a great resource for students and anyone interested in learning more about the Coriolis effect. Are there any other resources you'd recommend for someone wanting to delve deeper into this topic?
There are many excellent online resources and textbooks that explain the Coriolis effect in more detail. Searching for Coriolis effect will turn up a wealth of information.
And this simulation is a great starting point to visualize the concept. Why is a simulation like this so helpful for understanding the Coriolis effect?
It's hard to grasp the effect just from equations. The simulation makes it visual and intuitive. You can actually see the motion, which makes it much easier to understand.
It's like having a virtual lab experiment right at your fingertips. Does this simulation have any limitations? Are there aspects of the Coriolis effect it doesn't fully capture?
It's a simplified model. Real-world scenarios are much more complex, involving factors like air resistance and variations in Earth's rotation.
But it's a fantastic starting point for building an understanding. What are some other interesting aspects of rotational motion that relate to the Coriolis effect?
Centrifugal force is another apparent force related to rotation. Understanding both is key to grasping motion in rotating systems.
So it's all about understanding the interplay between different forces and frames of reference. How does the Coriolis effect connect to other areas of physics?
It's deeply connected to Newtonian mechanics, particularly concepts like inertia and forces. It also has implications for fluid dynamics and meteorology.
It's a great example of how different areas of physics are interconnected. So this 3D simulation really helps demystify the Coriolis effect.
It's a powerful tool for visualizing a complex concept. Yeah.
That was a great discussion. Thanks for sharing your insights.